Hello and welcome back to Coding with Kenny G. This is the beginner series, and in this episode, or maybe this one and the next one, we'll be doing something really cool. We are going to be spawning some enemies into our little mini game here, where we have a turret that can now shoot bullets and they move through space. But we want some enemies to shoot at. It's going to be pretty simple. But I think that we can make it really cool with how the spawning works. So you're gonna learn a lot of neat little tricks. So first of all, let's pull up paint here. Don't we all love paint, huh? So our game, we have our guy here. This is our turret, our little cannon, and this is his sort of field of view. And then we can make like a little semicircle here where enemies spawn at random positions inside of here on this radius line, and they move towards the player. So you have to shoot like these incoming essentially asteroids or something like that and destroy them, and then you get points. And if they touch you, you either take damage or you lose the game. So we also get like a lose condition and essentially like a win condition of trying to get the most score. But this is pretty cool because this is a programmatic setup of this stuff. So let's move into the code. I think that I might need to spend an episode or two on this. I'm not sure yet, but we'll see. So we're gonna open up the turret scene. Okay, so the first thing that we are going to need is an enemy. So let's make that. It's going to be pretty ugly, but we don't care because we just want to make the functionality of all this stuff work. So in the hierarchy of the turret scene, I'm gonna right click, create a 3D object, and then this will be a sphere. Let's just make our enemies into spheres. And I'm gonna call this game object enemy. And I'm going to zero out its position in the in its transform. So 0, 0, 0. And here we have our ugly enemy. We're gonna figure out things like scale and stuff like that later. But the only thing that we need to do is to open up our prefabs folder. In the project view, open up the turret folder and then drag and drop the enemy into the turret folder to create a prefab of this guy. Then we're gonna delete the enemy from the scene because we're gonna instantiate this enemy through code. So I'm gonna delete that guy. And then in our materials folder in the project view, gonna open up the turret folder, and then I'm gonna create a material called enemy. That's it. And then we are going to open up our enemy prefab in the project view again in edit prefab mode. So double click on it. Now we're in edit prefab mode, and then I'm going to apply this newly created material, the enemy material, to our guy. There we go. Here we're in edit prefab mode, and just going to give this guy some color. Normally it will be a red or something, but maybe this guy is a yellow Power Ranger. So there we go. Yellow, why not? Okay, so we have an enemy ready to go, at least with its it doesn't have any behavior yet. But that's gonna come eventually. But now, in the turret scene, we are going to create an empty game object in the scene. So right clicking in hierarchy, select create empty, and this is going to be our enemy spawner. I'm just going to zero out its position in its transform component. So it is at the world origin. And that's it. Okay, save the scene. And now I think we are ready to start scripting. In the scripts folder, I'm just gonna create a new script called create mono behavior script, and this guy is gonna be called our enemy spawner. I'm going to apply that to our enemy spawner object in the scene, so I don't forget. Add component to the enemy spawner. Well, add the script called enemy spawner. And then we are going to open that up in Visual Studio. Okay, like I've said many times, whenever I create a script, I have these regions, but we're not gonna deal with that for now. Okay. Empty script, so nothing inside of it yet. You can delete the void start and void update. We're gonna add these as we go. Okay, so the enemy spawner, I'm gonna write in comment above here. Actually, I'm gonna teach you a new way to write a comment over several lines. So a forward slash, 2 stars and a forward slash. Then inside of that we can make lines of comments like so. Okay. The enemy spawner script, well, is responsible for spawning enemies into the game scene at runtime. We will spawn enemies in a random semicircle around the enemies at a random position in a semicircle around the player turret. We will spawn enemies at an interval over time. We can adjust difficulty and such with these tweakable variables. Cool, so that's essentially like a little description of what we're trying to achieve here. First of all, we are going to need to have a reference variable to the enemy prefab. So we're going to write public game object with a capital G. Enemy prefab is that variable called. And then yeah, we are going to add more to this script as we go now. I'm gonna write. We're gonna test this code in through the start function first, and then we're gonna set this up better. So first of all, I'm gonna write void start to just have the start function there. So that's ready to go. And then I am going to need to copy paste a piece of code in that I have written already because I need to think about it a little bit, but we're gonna write it together anyway. And I'll need to adjust the code a little bit for our use case in this scenario. So I'm just gonna go into another class that I prepared and copy paste that into the enemy spawner script below the start function. Okay, so what this code here does, this is a little bit of mathematics. I'm not good at math, so you know, I had to kind of learn little by little myself when it comes to math. Got help from the internet, finding some script that or way of thinking about how to do this. But anyway, we're gonna get a vector 3 position on a circle. So I'm going to comment out this code, and then we're gonna write it together, because I need to adjust some things there. So what's the goal here? Okay, we're gonna write public vector 3, because this function needs to return a vector 3. And then, oops, whoa, I just touched some buttons here. Okay, and then I'm gonna write get point on circle, and this function is going to take in parameter float an angle in degrees, so not radians, if you have heard about that. Angle in degrees, so it's easier for us to think about. Angle degree. Then it's going to take in a radius. So basically, how far out do we create a circle from a center position? I'm going to display to you properly how all this stuff works. So float radius, and then we're going to send in a position that we regard as the center of the circle. So vector 3 center. Okay, and that with an opening and a closing curly brace. And then we are going to write. We're now going to use a little bit of math. I got, like I said, I got help from the internet with how to write this stuff, but I'm going to try my best to explain the code as we go here. So now we're going to get from the angle degree that is coming in. Let's say it's an angle of 45 or 90 degrees, right? We're going to convert that to radians, because trigonometry functions, so triangle mathematics, typically runs on radians. So I'm just going to write float rad is equal to angle degree, and then we're going to multiply that by a special function within a math library that is given by Unity. It's called mathf. Dot degrees to rad. So this is a way to convert. They give like helper functions to convert values between these two different ways of considering angles, and yeah, so either you use radians or you use degrees, but we are converting the angle degree here into radians, and then we're gonna write float x is equal to, again using the math f library, so math f, and we're going to get the sin, sinus and cosine, sine and cosine in English, right, of the triangle that we are constructing here. So we're going to get the sine, sending in the radian value here, and we're going to multiply that by the radius. And then we're going to do the same for the cosine. So float y is equal to mathf dot cosine, so COS short for cosine. Same, we're going to send in the radian and then multiply that by the radius. And then we're going to return the center position plus a new vector 3 where we're sending in x, comma, y, and 0f. I'm now gonna write this incorrectly, and then we're gonna adjust some things inside of this function here, because it's not gonna work exactly the way that we need it for our context where we are a top-down game, but I'll show you exactly what happens. So now we're gonna try to use this function. In the start function here, up top, we're just gonna instantiate our guy. So we're gonna instantiate one enemy at a given position. So I'm gonna write instantiate inside of the start function. What are we going to instantiate? Where and at what rotation? So the thing that we're instantiating is the enemy prefab, comma. Where are we going to instantiate it in the world? We're going to instantiate it on a position given to us by the function getPointOnCircle. I'm gonna display this visually, how this works. So I'm gonna write after the comma here inside of the instantiate function, call getPointOnCircle, and inside of the open and close parentheses we now have to send in a few parameters, right? So now I'm going to display to you what is considered 90 degrees by this function currently. So I'm just going to write our target angle is 90f. The radius of this circle is, well, let's just put it at some hard-coded number right now, maybe 5f, so it's a little bit wide. And then comma, and then what is the center position? Currently we're just going to use this enemy spawner's game object's position, so transform dot position. And then after the closing parentheses of the function call for getPointOnCircle, write comma. Then we're going to send in a rotation. We can just write a shorthand version for we don't care right now. We might need to adjust this later when we get into movement and such. But we're going to write quaternion with a large Q. Quaternion is the mathematical construct to describe a rotation. So quaternion dot identity. This means that the rotation of the object that is being spawned, so the enemy, will be 0, 0, 0. Then I'm going to end that with a closing parentheses and a semicolon. Okay. So we are instantiating an enemy prefab at the position given to us by the function getPointOnCircle, where we are sending in an angle degree of 90 degrees. I'm going to display to you where this function considers to be 90 degrees. So we're just gonna save this script for now and go to Unity in order to have some visual explanation here. Unity, let's go. Okay. And inside of the enemy spawner, in the scene, we have to apply the enemy prefab here. So I'm just gonna, in my project view, inside of a turret folder, drag and drop the enemy onto the enemy prefab slot. Excuse me, a little drink here. Okay. Now I'm gonna click play, and then we're gonna see one enemy being spawned in the game. And here you see we spawned one yellow ball here, so one enemy. This is considered 90 degrees by our get point on circle function. So essentially this is 90, and then it'll go around clockwise like so. Similarly, if I go back to the script and I write I don't know, 180 F on the first parameter here for the angle degree that we are sending in, saving the script. We'll see. That the enemy is spawning below us. So that's a problem, first of all. We're gonna fix that immediately, because back in the script, inside of our get point on circle function, we are constructing a new vector 3 here, where we are essentially saying what coordinate system do we care about here. Well, we are a top-down video game, so we care about the Z forward index and the X index. We don't want to use the Y value. So we have to change inside this function that the X value is X, Y is 0, and then the Z component of the vector 3 here, that's the Y value. And now when I save this script, go back to Unity once it compiles, let's see where this guy spawns when we send in the angle of 180. There we go. So 90 degrees was here, right? Then 180 is here, and so forth. But I'm gonna show you a little trick, because order of operations matter in a way. We want 90 degrees to be not on the right side here, but on the Z-axis up top here. The only thing that we need to do in the get point on circle function is to flip the sine and cosine calls. So x is equal to mathf dot cos, and then y is equal to mathf dot sine. Then we're gonna flip where essentially 90 degrees is. So if I go back, I'm also going to update this value, calling the get point on circle, and the angle that I'm sending in is 90F. Okay, so then we should see that the enemy is spawning above here. Yes, good. So this is 90 degrees. And let's then go back to the script and display what happens when it's what is it? Yeah, let's make a diagonal, right? So it's 135F. Save the script. Press play, and then it should be over here. Yes, 135, and then over here will be 45. So I can display that as well. If I write 45f, right? Sending in as parameter for angle degree. Okay, very cool. And here's the fun part. We can do this, the spawn position can be random within a range. So I'm going to go back to the Terra script, and instead of hard coding this value here, I can write a little local variable in the start function here called float. And then the name of the variable is random angle. And now I'm gonna type it out really concisely so that you understand. Random angle within bounds is equal to, and then we're gonna call the Unity random library. So that comes with Unity random dot range. So every time we call this function, either using a float or an int, you have to be decisive. It only takes like floats versus floats and ints versus int. But we are going to, we want a value that is within a boundary. So the smallest value is 45f, comma, and the largest value is 135f, right? And then every time we call this random dot range, it'll return a value within those bounds. So now we can replace the 45f, the hard-coded call in getPointOnCircle, with the variable random angle within bounds. And then every time every time we run start now, we're gonna see different spawn positions every time within those bounds. Gonna save the script and go back to Unity and just go click play a few times, because now we're gonna see this guy spawn at different places each time, right? That was close. Yeah, there we go. Yeah, we had a one where it sort of spawned. Yeah, it's going to be different every time we call it, right? So that is pretty neat, and this is going to be what we're going to be working on. Yeah, I see that we're going to use an episode or two more on this to really tighten this stuff up. But this is really cool. This is how we can make the game feel like it's emergent gameplay, that you have to react to randomization, for example. That's pretty neat. In the next episode, we're gonna try to clean this up and do a proper function calls and spawn some more enemies at intervals of time, which is also very cool. So I'll see you in the next one.